Are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at tree level. So in this video, what we are going to do is, after having talked about the concept of primary indexing, we are going to move ahead and talk about secondary indexing in DBMS. Okay, so let's quickly get started on this. So secondary indexing in DBMS can be generated by a field which has a unique value for each record, okay? And it should be a candidate key. So if you want to apply the concept of secondary indexing, right, in a DBMS or in a database, right, you can generate it for a field which is kind of like a candidate key, okay? It is also known as non-clustering index. So you must have seen that when we were drawing classifications over here, we classified primary, clustering, and secondary, right? So we can also classify it as primary, clustering, and non-clustering as well. So we can say that secondary clustering is also known as non-clustering indexing as well. Okay, so this two-level database indexing technique, right, basically is a technique to reduce the mapping size of the first level. Okay, now for the first level, a large range of numbers is selected. Because of this, the mapping size always remains small. So what you can do is you can keep the first level of mapping, right? So this is like a two level of mapping that we are introducing, or two level of indexing. That is why in the first level of indexing, you can keep the range large and then you can reduce it in the second level. Okay, let's take an example over here like we always do in order to understand the concept in the best way possible. Okay, so what happens is in secondary indexing, we can take off an example with a database index example. Now, in an account or in a bank account database, the data is stored sequentially by account number, right? You have account number, let's say 101, 102, 103, and so on. Now, you may want to find all the accounts in a specific branch of ABC Bank. Okay, so if there is a bank, it may have a lot of branches, right? And at different branches, we have different accounts which are opened in that particular branch. Okay. Now, here you have a secondary index in DBMS for every search key. Okay, index record is a record that is pointing to a bucket that points to all the records with their specific search key value. Okay, so here you can think of it like this, that here all the account numbers, right, are basically stored at the very lowest level. After that, in between, the red one that you see is basically the bifurcation of the ranges done on the basis of branches, right? And before that is what all the higher level indexing that you require, wherein you are pointing to the very first record for each and every specific branch for a bank. Okay, you can also take an example like this over here, wherein we have okay, so what happens in this secondary indexing is, let's say here you have a search key, right? And here, let's say you have some attributes. Now this search key, remember, it should be a candidate key over here that is of prime importance for us. Okay, along with that, let's say there are let me introduce two more over here. Okay, it's the same key, the same thing is happening over here as well. We have search key over here as well, and we have like a few set of attributes after that. Okay, now in this, what I did was, let's say I basically again picked up a range of values. Let's say I picked from here, and I picked from here, and I picked from here. Okay, so I'm basically picking from all of them some of the defined ranges. Okay, this can be, let's say, one big place where all the account data is present for you. Okay, so let's say instead of this, you can define one as well, wherein this is the account number and some attributes are there. Okay, then in the first level of indexing, what you have done is you've kind of done the bifurcation on the, let's say, the bank number over here. So when you define the search key, okay, let's say the search key is the branch code over here. Okay, which is also present in here. Okay, so what you can see is here, as you can see, let's say this one is one that picked up. Okay, then here we picked up for 20, then here we picked up for 30, and here we picked up, let's say, for 40. Okay, now even for that, the second level of indexing that we can provide at the very root level can again be that, let's say, this and this belongs to one single account, so I can do 10, right? I can do 20 over here, and then I can do 30. Okay, so I don't have to pick all, I can pick some. So in this case, that is why it says in the very start here as well that you have a secondary index in DBMS for every search key. Okay, the index record is basically a record that is pointing towards a bucket. Okay, that in turns again point towards a bucket. So here you can see this is basically pointing towards again the pointer for a bucket. So everything again works in the concept of bucketing. So when you have this two level of indexing technique, you basically call it as secondary indexing in DBMS. Okay, and that's what the overall idea is over here. Okay, after this, the last one that we have is clustering index in DBMS. Now let's talk about the third one as well. Now what happens in a clustered index, record themselves are stored in the index and not the pointers. So far what you've seen in the indexing table is you have the index record, index key, and after that you basically have a pointer pointing towards a particular record. Okay. Now in clustered index, instead of storing the pointers, you actually store the record themselves in this particular scenario. Okay. Now sometimes the indexes can be created over here on non-primary key columns as well, which might not be unique for each record. Okay. So sometimes the index key is not unique, right? It might be repetitive as well. In such a situation, you can group two or more columns to get the unique values and create an index which is a clustered index. So here, since I am saying that you might pick when you are doing indexing in clustered indexing, right? There is a situation where here the key that you are picking is not unique. So in order to make sure that the uniqueness still persists, what you can do is you can combine, right? Or rather the word that you use to remember over here, the concept as well, is known as cluster the columns, okay, to basically create a unique value. So that basically helps you to identify the record even faster. Okay, now let's assume there is a company that recruited many employees, okay, in various departments. Now in this case, the clustering index in the DBMS should be created for all the employees who belong to the same department. Okay, now it is considered in a single cluster, and index basically points toward to that entire cluster as a whole. Here department number, remember, is a non-unique key over here, but department number basically clusters all the employees in a certain department, correct? So if you have storing the details for all the newly recruited employees, right, many of them might have common departments, many of them might not have common departments as well, right? There might be 4 employees which got let's say recruited in the business department. All of them will have department number as, let's say, 4, okay, if that's the correct number. Now I am doing clustering based on the department number, so that means all the employees who got recruited for a certain department, they will belong to the same cluster. So here department number is used for doing the indexing, whereas department number is not a unique key, it is a non-unique key. Okay, so when you do basically clustering based on the concept like that, it is known as clustering index in DBMS. Okay, remember in non-clustering, in secondary, you basically have to make sure that the indexing is done in such a way, right, that all the index records that you're picking are unique and are candidate keys. But in clustering, you don't have to ensure about that. Okay, so that's what pretty much the overall idea is over here. So this is what pretty much is about the concept of clustering. right? So we have completed all the three types of indexing that we can talk about. Primary is when you are doing indexing based on the very primary index, right? Then we talked about clustering indexing and non-clustering indexing. Non-clustering indexing is also known as secondary indexing. In secondary indexing, you basically try to add two layers or two levels of database indexing over there, right? In the first level, we have basically each and every record, right? That is basically pointing towards a bucket, okay? And then it is again pointing towards to all the records with a certain specific search key value, okay? But when we talk about clustering indexing, in clustering indexing, we first of all do not want to keep the index record as unique. That is definitely not at all the criteria. Apart from that, we try to cluster all the records based on some common attributes. For example, you have some students in the first semester, some students in the second semester, in the third semester, right? So you basically want to group all those students in the same semester as one, right? And you want to put all of them in the same cluster. So that is what the idea is about clustering indexing. In non-clustering indexing, you want to put all the, I would say, attributes, right? In the non-secondary clustering, you basically want to choose the candidate key, whereas in clustering indexing, it is not at all a requirement to basically have one or unique index records. So after this, one more type of clustering indexing what we have is, it's more or less like a classification and more like a way of doing indexing. It is known as multi-level index. So multi-level indexing in database, it's basically created when a primary index does not fit in memory, okay? In this type of indexing method, you can reduce the number of disk accesses to sort any record and kept on a disk as a sequential file. Okay, so the idea is, usually what it happens is, sometimes the data is so big, right? And apart from that, even the indexing that you do now, even that is also stored in the main memory itself. So the idea grows so much, right? The space taken in the main memory grows so much, is that you try to assign levels in indexing. Okay, at the very first level, right, you are basically indexing, let's say, on and creating some buckets. Even for those buckets, you have one identifying attributes, and even for those identifying attributes, you add another level of indexing. Okay, so it's like something like this, wherein you have the data blocks over here, like the real data blocks, which are actually grouped together. So these are all one only, but you've actually grouped them together. And after that, even on top of that, right, here you basically grouped them together and kept a record, right? And then you, let's say, kept them together and kept a record. And even though these two you kept record, and even for this now, you can combine these two and assign a indexing. So although this kind of slows the process a little bit, but it takes less space and it is a little bit faster in terms of access as well. Whereas if you are doing a lot of data and if it's very dense, it becomes a little bit difficult to do the indexing, whereas it basically creates a sparse base on that file, right? You start with a very sparse base and then you move ahead on that. So that is a very good way of actually doing indexing, and multi-level indexing actually comes very handy as well whenever there is a use case where you have to deal with a very large amount of data. So you have outer blocks which are divided into inner blocks, which are in turn are actually pointing towards the data blocks. Okay, so that's what pretty much the overall idea is over here when we talk about one more type of indexing, which is known as multi-level indexing. Now, we saw so many advantages of indexing, right? We talked so much about what all we can do with indexing, right? What are the different types of indexing available, and each of them have a different use case associated with that. But it's also important to note what are some of the disadvantages that are associated with indexing. So in this slide, we are going to take a look at some of these. So some of the important drawbacks and cons, or I would say disadvantages of indexing are: first, to perform the indexing on the database management system, you need a primary key on the table with a unique value. You might index or you might not index on that primary key, but you definitely need a primary key right, on the table with a unique value. Apart from that, if it is not present, it is not possible at all to do indexing on the database management system. Apart from that, you cannot perform any other indexes in database on the index data. So if some data is already indexed, you cannot do any other type of indexing on top of that. So you have very limited options available. Apart from that, you're also not allowed to partition an index organized table. So if there is some table, if there is a database which has already been indexed very well, you cannot do partitioning of that database. So partitioning of database is a very good way again to make sure that the access to information is faster. But if the indexing as a technique has been applied to a database, partitioning as a database is not allowed to be done. Okay. Apart from that, when we do SQL indexing, it decreases the performance in terms of insert, delete, and update query. So when you're doing indexing, the select query is definitely optimized because you're reaching to the required record way faster. But also understand that because of that, the insert, delete, and the update query becomes slower because they are now kind of dependent on not just on the main table, but also on the indexing table as well, where certain changes are required. So although you are optimizing on the select queries, but also understand that you have to deal with the decreased performance of increase, insert, delete, and update queries as well. Okay, so that pretty much concludes our entire idea for indexing that we have, right? This is a very small series of sessions where we are dealing with indexing. Indexing as a technique, you don't have to go in very deep and in detail, but you have to understand how does the overall idea of indexing works. We started our discussion with what indexing is, why do we really need indexing, and then we basically triggered our discussion to different types of indexing are there, because you should be knowing about all these techniques. So I hope it was helpful for you to understand about this overall idea, and you were able to pretty much define and understand the aspects around indexing as well. Indexing is something that is very popularly used in databases, and it is something that you should do and include in your databases as well. As per industry practices in MySQL databases or any database management system, indexing comes very handy and has proven great performance, I would say, benchmark that it can actually reach. So I hope I was helpful in explaining you this topic to all of you. Thank you so much for taking a look at this video, and I'll definitely meet you in the next one. Thank you.